Alright, I picked a few examples and hopefully you find it helpful. Hopefully you will. The first integral is definite integral and it is pretty easy. So I'm gonna go fast. It involves the u substitution, obviously, because this inner function 3x plus 14 is this whole function is composite function, so you can't really solve this integral instantly. You have to replace 3x plus 14 with u, and then du becomes 3 dx. Therefore, dx equals 1/3 du. Now we're ready to express our new integral. Do not use the same boundaries because your integral is going to be in terms of u. We have the square root of u. Now dx is 1/3. Let's pull it out. Du. This integral is easy to solve. I'm sure you can do it in seconds. Let me write it down actually. You can express square root of u as u to the power of 1/2. So then you just do u to the power of 1/2 plus 1, 1/2 plus 1, and then you simplify, and then you get 1/3 u to the power of 3 over 2 over 3 over 2. Then you flip it, you get 2 over 3, 3 over 2. Oh my god, I almost forgot to put that cupcake. But you know what? We don't need it because this integral is not indefinite integral, so I can forget about this c because I won't use it. So I get 2 over 9 u to the power of 3 over 2, and now I'm going to go back to my original version. So that would be 2 over 9. U is 3x plus 14. And that whole thing is to the power of 3/2. You can use radicals, express it in radical form. It doesn't really matter. If it's multiple choice, then you look at your choices and see which one you want to pick, the rational or radical form. Now all you have to do is just plug in. So I hope you can do the rest, so I don't have to go through this simple process. Now we're going to do the second problem, which is integral, sine to the power of e to the negative x over just e to the x dx. So when I look at this integral, I notice I have e to the negative x on the top as a part of sine, and on the bottom I have just e to the positive x. So I'm thinking to myself, oh, if I had on the top and on the bottom as my inner function e to the negative x, then I could use a u substitution and just replace e to the negative x with u. But I can't do that because I can rewrite this integral as a sine to the power of of e to the power of negative x times e to the negative x. I'm going to put dx in parentheses. You'll see why. Because 1 over e to the power of x is the same as e to the power of negative x. Now I can use the u substitution. It's going to make better sense. E to the negative x we're going to replace with u. Therefore, the derivative of e to the negative x becomes negative, the chain rule, obviously, e to the negative x dx. Now, if you compare this part to this, you notice we just have this little negative, which we can get rid of by expressing e to the negative x dx as negative du. All right, now back to our original form. We have the integral, but we're going to use the integral in terms of u. So sine of u, I'm looking at this integral right now, and negative, let's pull it out, du. This is very easy to solve, don't forget the negative. The derivative of sine, integral of sine is negative cosine. I almost said cosine, which is another common mistake. Why? Because the derivative of cosine is negative sine. So you need to put another negative here. Well, don't forget the cupcake. And your final answer is going to be cosine of e to the negative x plus c. Now, let's do the third problem. Actually, I'm going to move to the next page. The third problem says you have cosine squared 5x sine of 5x dx. Indefinite integral. Now, obviously I have to use the u substitution, but which one is going to be my u? Sine of 5x? But which one looks more complicated? Cosine squared 5x, because you have that little square on the top. So that's why you want to express that inner function, cosine of 5x, as u. Let's see what happens. Therefore, du equals, the derivative of cosine 5x equals, by the way, the chain rule, so you have to pull out the 5. Derivative of cosine is negative sine, don't forget the negative, of 5x dx. Now if you compare this part right here to this, you notice you have exactly the same thing, so you can express sine 5x, I'm sorry, looks a little messy, sine of 5x dx equals negative 1/5 du. Okay, now I'm ready to write my new integral in terms of u. Now cosine 5x is u. So we have u squared negative, you know what, let's pull it out, negative 1/5, and just put du. This integral is easy to solve. You can do it in seconds. It's e cubed over 3 plus c. Back to the original form, so we get negative 1/5. U is cosine of 5x. You can put the whole thing cubed, or you can put cosine cubed of 5x. I like that better. Over 3 plus c. The final result is cosine cubed 5x over 15 plus c, or you can say negative 1 over 15 cosine cubed 5x plus c. It doesn't really matter. Now we're going to move to the next problem. That's number 4. Cosecant x over 2, cotangent x over 2 dx. And you have the boundaries here, the limits of your integral are 5 over 3, pi over 3 and pi over 4. Now this is very important. I picked this problem on purpose. When you look at this expression, okay, before you even think of the u substitution, you need to remember, actually you need to memorize all of those popular, important integrals that we learn by heart. The integral of cosecant x and cotangent x equals to negative cosecant x. Okay, and if you forgot, then you need to pull out your notes and just sit down and memorize all the formulas. Okay, that's very, very important. But here I have x over 2, and I don't want x over 2. So I'm going to replace it with u. And then I get the derivative of x over 2 is just 1/2 du. Therefore, oops, sorry, dx. Therefore, excuse me, dx just equals 2 du. All right. So don't use the boundaries because your integral is going to contain the new variable u. So the whole thing is going to change. You'll use your limits later. So we have cosecant of u, cotangent of u, and dx is 2 du. Now, as I said, the derivative the integral of this equals to negative cosecant. So that equals to 2 negative cosecant of u. I don't want to put plus c because I'll be using these certain boundaries later on. So we get negative 2 cosecant, and u is x over 2. Therefore, after you use your boundaries, you get negative 2, let's pull it out, cosecant, pi over 3 divided by 2 would be pi over 6, minus cosecant, pi over 4 divided by 2 is pi over 8. At this point, I would stop because I can figure out cosecant of pi over 6, but pi over 8, I guess I would keep my answer like this because I'm not allowed to use a calculator at this point. But on multiple choice, they would give you something different, like better angles, something that you can work with. So that will be easier. All right. Now we're going to do the last problem. To me, it's also very important. A nice problem, I like it. And it is indefinite integral, ln 3 x squared plus 4 dx. Of course, you can't solve it right away. You do need the u substitution, but the question is, what do you want to replace with u? Now, I do want to get your attention here. See, ln of 3. So the students sometimes get confused. It's not ln of x, it's ln of 3. So that means you're dealing with a constant. So why don't you pull it out now so that you don't have to deal with it? And now it doesn't bother me. It's outside. Now I'm just going to stare at this new expression, x over x squared plus 4, trying to determine what I want to replace with u. And obviously, the more complicated expression would be x squared plus 4. And exactly that's what I want to use in my u substitution process. So that would be du equals 2x dx. Now, if you compare your x to dx part to this up here, or right here, you notice that x dx can be always replaced with 1/2 du. Perfect. Now let's write our new integral. 1 over ln 3 integral. Now x dx, we said it is 1 over 2 du, but you know what? Let me put it first. Okay, so all I have here left is du. Now 1 over x squared plus 4 we replace with u and du. Now we can solve this. First you start with 1 over 2 ln 3. You know what, it depends on your choices. If it's multiple choice, they might express it as 1 over ln 9 because this is the same, the denominator is the same as ln 3 to the power of 2, which is ln 9. So it doesn't really matter. This 1 over u Integral of 1 over u is one of those famous ones. It represents ln, don't forget the absolute value, of u. You're dealing with the indefinite integral. Plus c, don't forget. And that's it. So we get 1 over 2 ln 3. ln and u is x squared plus 4. And plus c. Now you're done. As your final answer, among your choices, you might see something like this, or something that doesn't involve these. You see this absolute value? So you might get, as your answer, you might get something like this. Okay? All right.